Hello everyone, welcome to another Bifrost workshop. Today we'll be working on Bifrost Dev Kit, which is our Foundry based kit for developers to start building on top of our L2 SLPX protocol. Essentially, you can leverage this protocol to be able to mint and redeem LST. Especially, you have all of the functionalities plus Oracle set up inside for you to be able to, build a lot of stuff, right, with LST. So you think a little bit deeper. LST essentially has a yield baked in. So think about an asset that has yield baked in, and then you can use that for, a lot of stuff. So today I will be walking you through how to use Bifrost Dev Kit, and kind of explain the inner workings, plus how to build, and we will be building a Yield Delegation Vault together. Of course, it does have that inside the Dev Kit. However, I would delete that for this workshops, and then we will build that thing together. Then yeah, we'll see what happens. So let's get started. So the best way to get started is you go to GitHub. You go to github.com, buildstation.org, bifrost dev kit. You go this link right here, which will be included inside the video. Go to code, get a git clone. All right, so you go here. Let's go to this walkthrough. All right, there's something here, and it's gonna git clone. All right, this one. And you clone it to your local machines, right? So it's gonna be Foundry based. So make sure you install Foundry. So let me just grab this one. So you're not aware Foundry is framework for you to be able to develop Solidity. There's three essentially on in EVM. There are three major framework for you to build. One is actually Remix is not a framework, it's more of a IDE. So you go to remix.ethereum.org, this one. All right, so you can write, your contracts, everything in here. Or you also have something called hard hat. I believe it's this one. You have hard hat, and you can build with hard hat, and it basically a framework has all the toolings, everything for you to be able to build Solidity. Foundry is another one. I much prefer Foundry compared to like Hard Hat and and others. Mostly because Foundry, for me initially when I used Foundry, it was mostly because you're running tests in Solidity. It makes it, and also because it initially was very fast to compile, very fast to write tests. It can run tons of tests really quickly, and sort of like just easy to use. Unfortunately, initially it didn't have a very strong dependency system, but lately it has upgraded to get Soldier, which is like a much more capable dependency system compared to the other one. But yeah, so let's get back into this one. So you git clone that to your local machines. So now you go to Bifrost dev kit, right? Okay, and just whip out my cursor. Okay, and no, I don't need that. So you have all these things. You have basically a lot of stuff already set up for you. Got the ABIs you want to. This is for your front end. Right? You want to grab those. You can grab these. It's just for front end. These are just broadcast. Got some docs here. Deployments, everything. And I highly recommend if you build things with this, and if you're willing to, you can also open a pull request and contribute some stuff for the rest of the community. You also got like deployment script and so on. I got interfaces as well. Yeah. So alright. So let's here. Let me forgot to do one thing. So these ones right here is gonna give you error because I didn't install dependencies on these ones. So let's just quickly install dependency. Let me just see. Yeah. So I'm using Soldier, which very convenient dependency management system that comes with Foundry. It's right here, Soldier, and they maintain like a dependency system, very convenient. and you'll be able to essentially, you know, like build stuff with it and makes your life a lot easier. You got these things, and see, and it works now. All these things should work. Boom, boom, and boom. Okay, so now let's delete this Yield Delegation Vault because we will be building this together. I don't want to spoil on the fun for you, but we will be based on the this ones, and we'll also delete the test one as well because it's gonna give me an error. Yeah. All right. So I delete everything. So this is basically what you're starting with, and you have this one. Forge standard test.sol, and it should, oh, it's just the remappings. Okay, let me just remap this one. Dependency, there's the one. Okay. It should be source. Okay, let me. Okay, that should fix it. Yeah, there you go. Okay, so now you have all this stuff going on, right? So a quick way to get started is just gonna run forge build, right? And forge test. Boom, right? So if all your test checks out, your build works, then that means you have forked it successfully. Everything works. So yeah, so it makes your life a lot easier. Yeah, but basically you know that everything works right out of the box. All the test cases runs. You're gonna need some env. I will walk you through on how to set up like on these env and stuff very soon. All right, so let's get into this one. Okay, so let's get started with building the Yield Delegation Vault. Oh, delegate vault. That's so. All right, let's get started building this one. Okay, so first thing first, for Solidity, you want to add of course, you always want to have the SPDX license identifier. Most likely is MIT. Well, sometimes you have BSL as well. But yeah, whichever one you use, make sure you have one. You can go to SPDX, I believe it's .org, if I'm not mistaken. And you have like a list of like, oh, SPDX. Oh, there you go. Like the SPDX, System Package Data Exchange. Oh, is it? It's SPDX license list. Let's make this one. There you go. You can grab this one, so you can do MIT, which is over here. Oh, there's multiple MIT. Yeah, MIT license, BSL, G, what's that? GNU, AFL, whatever. Tons of stuff here. All right, so you grab one of these, whichever kind of fits you, and just slap it in. Keep that in mind. Okay. Okay, so now next thing you do is write a contract. All right, so you're gonna do Yield Delegation Vault. All right, so you can have this one. All right, so first thing we do, I believe the vault should have some sort of like ownership. So let's do import ownable. All right, and it's gonna auto fill to is ownable constructor delegate. All right, just grab the ownable component, right, from OpenZeppelin. Right, makes our life easier. The next ones, we're looking into. Let's see. We need to import the contracts, like the L2 SLPX, because we will be interacting with them. So L2 SLPX from source / okay, no, that won't resolve. It's gonna be from L2 SLPX. Usually I like to go from source. It's easy to infer, and we're gonna have v dot because we will be calling from there. Okay, inference is kind of really bad for this right now. from that. And also I would like to, do I need to get the interface? Let me double check. Do I need to get the interface? I don't think I need. Yeah, I think just that. Oh, I found little error right there. vTop. Huh. What the hell? AI is getting whacked today. See, it's like giving me these like weird suggestions. Unrelated, man. Don't give me these suggestions, okay? Yeah, start doing these things. Yes, it's not always good. Okay, so first thing we have the constructor. We need to initialize these things. Alright, so let's I usually like to stylize my stuff a little bit, just so it looks kind of pretty. So I grab these ones. Constructor. So you're gonna want to have the owner. You want to have the SLPX. You want to have v dot ve. This one address it in. Great. Now it's actually do a good job. To do the autocomplete. Okay. What's the issue here? Undeclare identifier. What do you mean undeclare? That's not the issue though. Okay, looking to initialize the new stuff. Oh, I see what it is. I probably need to declare somewhere. I probably would need to do a state variable sections. I probably do separate declarations to make it a bit more clear. Let's do some declarations. State variables. We are looking at. Okay, you have L2 SRPX, public immutable, v dot public immutable, and ve public immutable. Okay, great. Now you're gonna start doing. I'm gonna need to do. So each deposit is gonna have attached an ID. So I'm gonna need to add some ID into it. So you into 56. It's gonna be public, and it's gonna be current deposit ID. Alright, so I'm gonna add an ID to each of it. And that would be for the constructor. That works great. Okay, the next one. Let's work out the core logic, and then we'll start adding stuff in as we go, like core logic. Let's say we're looking at function deposit. Right? So deposit. So we are looking to add the address. Right? Token address that we want to deposit in, and it's gonna be u into 6. It's gonna be an amount, and that's gonna be public and payable. Because I don't think you need to be payable because it's on ERC20. Yeah, because it's VE, so you don't need the public payable. Just say public. You don't need to receive ETH. So we have two flow, right? So if token address, so we have to, at least for this one, I'm gonna do restrictions. So if if a token address is not address of v dot, right? Of v dot, and it's not token address of v ETH, it will revert. Right? I don't want people to put random tokens in because I only want those two. Because I just want that, right? So that's gonna be an error, right? And that's gonna be, I'll need an error sections. So I add an error sections, and it's gonna be error invalid token address. I'll make it a bit descriptive, right? So kind of easy to refer to token address. Good. So if it's like that, then it's revert, right? So go down. So now if it's token address, you go to address VE. Okay, if it's VE, I have to think about. So first I need to transfer from. So I gotta do VE dot transfer from. Alright, so then this will automatically error if people don't give me. Do I need different flow? It's different address. Slightly different interface. Do I need different thing? I don't think I need different one.
because I would get the token address anyway. I don't think I need. I think I can make some improvement to this one. Let's make some improvement. If I would just say though, if just directly. Okay. So it's whichever address it is. Okay, but okay, let's just lock it in for now, and then we will think of optimization later. Because otherwise we're gonna get paralyzed by overcomplicate everything. It's easy for AI to just like repeat my work without needing me to like abstract it too much. So yeah, 256. So we need to get a deposit conversion rate, right? Deposit conversion rate, and this deposit conversion rate is gonna come from L2 SLPX dot get token conversion info, and that's gonna be address VE. I'm surprised it's not doing a very good job at. Oh, okay, good. Very poor inference, I guess. Man, I thought the type is well spelled out. Got the interfaces too. Maybe should be importing the interface. Okay, anyway. So you are getting that one. Maybe let me switch up to interface. Maybe interface and that one. Okay, let's see if it does a better job inference. Alright. Let's see. Okay, add to SAPX. SPX dot. Huh. Yeah, it's somewhat okay, but it's still kind of bad. So it doesn't really matter. It doesn't matter. Anyway, okay, let's get to that one. Then you go down. So now we're gonna do. So you get the deposit rate. So now we're gonna need to have a mapping to like connect these ones together. Right. So let's get a mapping sections. Let's get mappings right here, and let's just put it just above these guys. Right. Mappings. And we're gonna have a mapping for mapping, and first thing is gonna be address to. I'm gonna do depositor record, right? Is it Terra? Because I want to support people having multiple deposits. I can deposit. So think about like liquidity. You have done the LP before, so like you can open like multiple liquidity positions, LP positions. So I can do depositor record. I think this one's easiest for calculations, right? Depositor record. So now I need a struct, right? I need a struct sections. So I'll just do a struct and enum sections up here, right? And it's gonna be a struct, and it's gonna be struct depositor record, and I'm gonna do as UN256 an array of deposit IDs. So everyone will have because every single time we have a deposit, this values will increment up. So you get deposit IDs here, and then you have an array of them, and then you're gonna have UN256, and you can have total number of deposits. Alright, this one to make it easy for front end to do. So then let's just stick to this one for now. Next one, we're gonna do. Stop. Okay. No. Yeah. So address to depositor record, message sender. Yep. Push. So the one that's calling this functions, you push the address in, deposit IDs, and you push the current deposit ID in, and then what you gotta do next is you increment address to depositor records, and yes, you always transfer before. And you increment that total number of deposit, current deposit IDs. Probably do this one at the end. So what I need to do before is I'm going to do deposit ID to deposit record, right? Oh, okay. So now I need a new mapping. Okay. So I need a new mapping. It's gonna be let's see, because now we're gonna have each deposit. So you have a deposit record, and then each of them would be a depositor. Each of the record will have its own, like a structure. Right? So you're gonna do uint mapping uint 256. Now that's gonna lead to, you're gonna map that over to a vault deposit record, right? And this will be public deposit ID to deposit record. Okay, that follows my naming scheme. So you're gonna have vault deposit record, and it's gonna be address. Nope. Goddamn inference. It's gonna be deposit ID. Okay. Then you're gonna have uint 256. It's gonna be index. I'm gonna add this one in depositor record. I'm gonna get the address of the depositor, right? Depositor. Yeah. And I'm gonna do address, token address. I'm gonna do uint 256. I'm gonna do amount deposited. The reason why I have this index, just so we don't have to loop over the deposit record. Let's say I need to query a specific one. I don't need to loop over it. I just need to because there will be cases where you want to loop, where you want to do locate a specific deposit, and you will just want to nail it down. Okay, this is in this index, and the cost of adding that in this stage is very minimal compared to if you have to loop over a massive list. It's just gonna be insane. So it's better not to do that one. Deposit conversion rate. Okay, good. Okay, and you got these ones. That's deposit vault deposit record. Okay, good. So now we go to deposit part, and we're gonna have to add this part in, and it's gonna be current deposit ID vault deposit record. Yes, deposit ID. I like to be explicit. I guess in Solidity it's okay to be explicit because it's probably preferable that way. Got the amount, you got token address, you got all these things. Okay, that's locked in. And what is it? Expect comma. But oh yes, you need to do this. Yeah, it's like a JavaScript object, right? So you need this. It's curly braces. Okay, and then after that you just index it, and I want to emit an event. Okay, so let's make some events. Alright. I usually just copy this. I have a list of these ones, so I usually just copy, because all the styling, it's annoying if you do it manually. So someone made it, I just copy it from them, right? Now I'm gonna index user, so this is gonna help our backend, right, to do some indexing. And deposit ID, address, token address, you in the amount deposited. I just do this one, deposited amount, deposit conversion rate. Okay, good. So we got a deposit event. So we got that one. Okay, so this one you got current deposit ID, you got the address, you get amount, deposit conversion rate. Boom, done. Good. Okay, good. Is there any errors somewhere? No. Okay, good. So now, okay, so instead of using else, so we'll follow the same logic, right? Okay, I will double check. Don't worry, I will double check to make sure that actually does a correct inference. Transfer from, deposit conversion rate, address, token conversion rate, push, okay, total index, yes, total number deposit -1, okay. It's the current, basically this one basically means the current length, and because index starts 0, right, so you subtract 1 and then you get the latest, because it keeps getting higher behind it, right? So you have like say index 1, index 2, index 3, index 4. So you know like where these are structured inside. Makes it easier later on if you want to do any sort of like, okay, I want to locate which which ID it is this, does it actually belong to this user, that kind of stuff, right? So makes it easy. Well, it always makes it easy later on. Okay. Oh, okay. Actually, I'm just gonna use the actual. You can use the other one, but use the actual. It's practically the same thing. Oh, the other one's easier to read. Right. Okay, and that should be our deposit functions. Okay, let's do function withdraw based on deposit ID only. Okay. Okay, so now you're gonna have, first you have to like spawn it out. So deposit record, memory, deposit record. So you get the ID and you look it up in the mapping. You got deposit ID to deposit record, right? Deposit ID. So you pull out the record. So you have to check if depositor is actually a message sender. So then only the guy who owns it actually actually can call it, right? So not depositor, right? I feel like this. Not depositor, right? I think I also would check if oh, I think it should be beginning, because it could be 0. So if deposit oh wait, because you look up something and it returns 0. So if deposit record go to invalid deposit ID. So you're gonna do something like this. Invalid deposit ID. So someone aiming to pass in an invalid one, right? So you're just gonna spot it immediately. Right? If it's like 0, if it's a vault deposit record, you're getting deposit ID. If it's 0, if this one's 0, if this one is the address 0, if this one's address 0, if this one's 0, 0, basically it's like not existing. Right? So then just revert is an invalid deposit ID. So I think just good to do an extra check. Why not? Right. Okay, so now we have to like work out the logic for you to convert them. So first thing, you need to get the withdrawal conversion rate, right? So you'll be able to tell the difference between them. So withdrawal conversion rate, and withdrawal conversion rate. That's gonna be equal to get token conversion info, and you load that in. Okay, good. And now then the next thing is like you want to calculate the total into the physics. So based on the image we looked at before of underlying deposited, right? So you calculate the actual amount that is the amount of underlying asset equivalent that has been deposited. So you have deposit record dot amount deposited, and okay, that's gonna be a little trippy here. So the amount deposited is gonna be so you want to divide this one. So deposit record dot amount deposited, and you want to divide this one with the deposit record dot deposit conversion rate, right? But this one is 1 to the 18, because if you look into this one, conversion rate, goddamn conversion rate, token conversion rate, is, oh, this one is the interface. Okay. Token conversion rate. Alright. Token conversion. Oh, I think I made it inside this one. Token conversion rate is to the e to the 18 right here. Right, to 18. So if you divide them, very likely you because this one is same e to the 18. So then this one you need to e to the 18. Alright. So you multiply it up just so you don't have routing issues. Okay, then the next thing you do is you would go to here, you enter 256, amount to withdraw, right? And it's gonna be equal to amount of underlying deposited. You gonna, no, not this one. So you're gonna multiply by the withdrawal conversion rate, and you divide by 118. That works that way. So you will have, now you have the amount to withdraw. And you need to do like the actions before you withdraw. So you have to remove the deposit ID from the depositor record. Alright, so you have address, deposit ID. Alright, so this is where you don't have to. So you just go deposit ID is deposit record, and you check the index, right? And then you just okay. So this is how you remove. So remove deposit ID from depositor record. So you go to this mapping address to deposit record. You pass the message sender in, and so you would and then you look into the deposit ID. So you get the object, right? Deposit record, and then you get the list of deposit IDs. Right? So you like 1, 2, 3, 1. Could be like 150, 100 in that list, and then you're gonna grab the index in repository depository record, right? So it could be like index 2, right? Actually, no, let's do 1. You got 1, and now you want to remove it, right? You actually remove it from the array. So then what you gotta do is, you gotta do this idea is called pop. You essentially will pop it out, right? You're gonna swap it to the last positions, and you pop it out. So you take address deposit record, so this is how you morph it, right? So you take that deposit IDs, and then you essentially you swap the position of this one, right? Of this deposit, the deposit ID at this index, you swap it to the whole length of it minus 1, which is the last positions. And then the next thing you do is you pop. With this pop, will pop out the last one in that positions, and then you reduce the total number of deposits, and then you get that one. And then the next one is you transfer, and you're gonna do a delete. Let me do delete. Delete, and you delete that. From the pop it out, and now with the deposit ID to deposit record, you delete that deposit ID. Right, boom, it's gone. And now you do a transfer. Transfer the vETH to the user. Alright, so vETH.transfer, okay, to user. You gotta emit, withdraw. Okay, I'm gonna need to get an emit withdraw event. I was gonna make 2 different events just to make it clear. For indexer, you index everything. What is this? Oh yes, this one. Just make a flip-flop on that change over there. Okay, and you're gonna emit, withdraw. Okay, good. What's wrong with this one? Okay, yeah. If it's like deposit ID, go to 0. So I guess you don't need to do the whole one. Just like if it's deposit ID is 0. Ooh, they do have a 0 deposit ID though, so can I do that? I think it should be address, because you shouldn't have a 0 address. So you got deposit, depositor. Just need to do this check. Address 0, the revert invalid. So if there's any deposit record that returns the address 0 as the depositor, then it just immediately like it's invalid because I only put in the message sender, so the 0 address shouldn't be calling it. So I guess that's the justifications. So withdrawal conditions would be the same flow, amount to withdraw, okay, and then you're gonna remove, and then it's gonna auto complete everything for me, and it's done. Alright, excellent. Now I'm gonna get a couple getters. It makes my life easier if I need to do anything. So let's get a couple getters here. First one is gonna be functions. Functions get depositor. This would be nice for a front end. Right. Depositor. If I want to query like directly on chain rather than doing like an indexing, so return that, and you got deposit ID, and you get that. Okay, good. Give it a loop and call out like all the details. I guess an indexer like is a little bit cleaner. And now I'm gonna need to do an owner functions. Alright, let me grab this. Okay, now we are getting into the owner functions. So we need to essentially at this point we need to set, you need to get a couple stuff. So one, we need a functions to allow the owner to be able to withdraw the yield. Okay, so based on our architecture, we need a way to kind of sweep everything. Yes, okay, so let's kind of think this over. Oh, sorry, I had caps lock on. For some reason, owner, withdraw, yield, right? And we're gonna do address, token address. So essentially, we're gonna ask the owner to pass in an address. Looking withdraw ETH or vETH or vDot. So if it's a token address, very likely we'll need to do a check. Check that. Okay, that's fine. Let's delete these two. Like inference is not always perfect. Okay, so now you have something like this. So let's logically, okay. What I think we could do is, so now every single so the user is depositing vETH and vDot, right? So you're depositing the liquid staking token. The amount that you're getting back will only decrease because the exchange rate between ETH and vETH will only decrease. Right? ETH will only lose value against vETH always. This is not a USD. This is not a USD value. It's relative to one another because the reward keeps getting baked into liquid staking token. That means the value of the liquid staking token will always increase relative to the underlying asset. That means as long as we have enough vETH to pay everyone, then we can just sweep the rest, right? So that means I think we need to add a couple stuff here. So first, what I think we could do is we can calculate essentially the withdrawal conversion. We need to calculate essentially the total amount of underlying that is needs to be covered, and then we multiply that with we need the total amount of liquid staking token to cover all of the ETH underneath, right? Because the original idea of the vault is, say you deposit X amount of vETH, right? And then what we guarantee is you will get back the same amount of vETH that is equivalent to the amount of ETH underneath. That means that means the underlying asset doesn't change, right? However much deposit you put in, the underlying assets that is supposed to pay out will not change, right? So then vETH amounts will change. The vETH value will change, but then the withdrawal amount for each depositor will not will change as well. It goes lower, but then the underlying asset as supposed to be payout will not change. So then what we can do is we'll make a small addition. So we go back up. All we can do is we can have UN 256, and we can do public. Oh yes, I think we gonna need to do that just so you need the minimum deposit, could be anything. But we will also do total amount of ETH deposited. Alright, so just need to make sure, and we repeat that for the dot, and we're gonna need another one to do withdrawn and amount for the amount dot withdrawn, right? Because let's say I don't want to withdraw on at once, or because like say I would, let's say like, you know, after 3 months I withdraw once and the yields keep getting added in. That means you need to calculate how much I have withdrawn. So then for me to be able to withdraw more after months, right? Because the idea is like the depositor, we just lock in their positions for a long term, right? Let's say you make a donations and you lock it in for a long term. Ooh, I think there's a design, something there where you be able to also issue a token, so for you to be able to free up that liquidity. But we will not get to that we will not get into that for this vault. All right, so we get these ones, and what you need to do, make a small additions down here in a deposit function. So first thing is we gotta do a check for minimum amount. All right, so amount, if the amount is less than minimum deposit amount, so we're gonna revert, right? So insufficient deposit amount. Okay, we're gonna revert that. And then what we're gonna do is every single time we finish the deposit, we're gonna increment that amount. So total amount of ETH deposited, not by the amount, but by the amount times 1E18 and divide by deposit conversion rate. Oh, I think I spotted a mistake. I need to move this down. The reason why is because if I increment that before, this current deposit ID is gonna be different than this one. So I need to move this one down. Okay, so we fix that. Okay, let's go to this one, and we're gonna fix this one as well. And we're gonna move this one. Move this one down. And there you go. Alright, awesome. Okay, now let's go down. Okay, so let's go down here, and we're gonna do let me just kind of think a little bit. Okay, so if it's vETH, what you need to do first is we have to follow the withdrawal. So we need to do withdrawal conversion rate, right? And then we're gonna do 256 total amount to cover underlying, right, equal to total ETH deposit multiplied by withdrawal conversion rate divided by 18. Okay, and then you're gonna have, let's just do total yield equal to vETH.balance minus that, and you're gonna have uint 256 available yield, which is the total yield minus total amount of ETH withdrawn. Okay, so if available yield equal to 0, then you're gonna revert insufficient yield. Alright, let's add this one on top first. Okay, insufficient yield. Let's go down. Okay, once you have that, then you always take the after. So ETH withdrawn, where you add the available yield And then you do a transfer, right? veth.transfer. Okay, you do a transfer, and you're gonna emit an event, which is owner withdraw yield, right? So do event owner withdraw yield, and it's gonna be somewhat simple, I would say. You're gonna have address index, but it's gonna be owner, and it's gonna be address token address withdrawn amount. Okay. No, we're gonna need available yield, right? It's the amount that we have withdrawn. So let's do withdrawn amount and withdrawal conversion rate. Okay, good. So we get all the information, and let's just add an extra. Okay, good. Let's repeat the process. Boop boop boop. Total about dot available yield. You revert. Mail. Available yield. Withdrawn yield. Transfer. And boom. Alright. Okay. And that should be it, right, for the owner functions. We do need a new one, right, because we have the minimum deposit, right, minimum deposit over here. Why did I have a minimum deposit here? So now we need an extra owner functions for me to set the minimum deposit amount. There you go. Something like this would work. All right, so we got to this part. So now after we finish this owner part, it's time for us to write some tests. So you got Yield Delegation Vault .t.sol. Alright, let's wrap some tests. We're gonna do very similar tests to this one. So let's wrap this one. Alright, because you're gonna have to initialize out to SRPX. The setup is gonna be different. All these functions will be very different, right? So you can refer to these, like existing tests. And we'll make a change to the name. Okay. All right. So next thing we do, we're gonna need to import the Yield Delegation Vault. All right. Okay. Then what's next? Oh, need to initialize it. Okay. I can do that. And now we'll do setup. I'll just create a new one, right? So we have all these things initialized, right? L2, SRPX, everything. I have all this one initialized. And 0.01 ether. Okay, not putting too little money. Okay, good. And you have VM deal 100 ether. Okay, good. So we have all these ones. Okay. Set token, VM prank, everything's good. Okay. Good. Now let's do the first one. It's gonna be test deposit vETH. Alright, let's do something like this. Public, get this. So first we're gonna start praying user. Alright. By the way, these addresses are mine. You can swap it out to yours for like for you to test something that's closer to anyway, so let's go to this. So first thing is SLPX. I need to create an order. All right. So I need to mint out something. All right, mint out like a bunch of a bunch of VE. All right. So I'm gonna send in this many, and it's gonna be address 0. All right, 10 ether. And L2, I'm gonna copy this one because it's like the first part of the deposit. Okay, so like this. But now I'm gonna make it bigger. Okay, I do 10 ether. Right. So check that the user has the correct balance of ETH. Alright, so we do a small check equal. Alright, oh no, not that. 7.9. Okay, because it's very similar to the other one. Now you're gonna need to approve. Alright, veth.approve. This one, address, yield, delegation, vault, and you want this to be similar to this amount. Right, so we approve this much, so we deposit this many vETH into it. Right, 1.6. These amount I've like pre-calculated, so it's easy for you to even like visually check it. So then you got deposit. So approve, you deposit. You need approve, otherwise it it will fail. Okay, you stop doing all these like autocomplete. So now we're gonna do assert equal. Right, to make sure that the yield delegation vault, we make sure that the total number of deposits are correct. Right. So total number of deposits are correct, and you're gonna need to also check deposit ID is correct. So let's do this. U into 56. Let's do an array, memory. You're gonna load up all deposit IDs. You're gonna do U into 56. Memory expected IDs, right? And you're gonna do, it's like 1. Okay, expected ID equals to 0. So assert equals, so I want to make sure deposit ID at the index 0 is gonna be expected ID equal to 0, essentially. Alright, make sure these are the same. And ID, okay, good. Depositor, I will check, get the vault deposit record of the deposit ID 0, check that it's actually user, good. Yes, set equal token address is equal to address that, okay, good. And this one is equal to that, good. And we also do one extra one, which is yield delegation vault. Make sure that deposit conversion rate is equal to ETH to conversion rate. Okay, good. Alright, so you have this one. Let's just run the test quickly. Alright, let's run the test quickly. Forge tests, and for you to run only one set of tests, you can do match path and specify the test file. And the V means that verbosity. So you do 4 is like very verbose. So it would have like tons of different on these like tracing for you to kind of like check how the storage getting updated, everything along the way. So you're gonna just start following the trace, right, on this stuff. And test pass. Looks good. Okay, so now let's go on to our next test. Test multiple deposits. Okay, so now it's gonna be very similar setup, right? Like this, and you're gonna also approve this, but now gonna deposit twice, right? And deposit, and you're gonna deposit again. Approve. No. I gotta deposit again. Alright, to deposit. Alright, stop prank. And gonna be very similar to the above. 2, okay. On the check, the 2, 0, and 1. Assert equal. Assert equal. Deposit IDs, and expected ID equal the same. Okay, good. So just check those two as match. And this one is just assert equal. And you gotta do this one. Okay. Okay. Assert equal version array, conversion array. Okay, something like this. Okay, let's run the test again. See how it works. Okay, 2 pass. Alright, so now you have it works for multiple deposit. Now let's do test withdraw the veth with new conversion rate. Alright, you gotta do something like this. So very similar. You're gonna have to start with some minting. Alright, some minting is gonna be 10 ETH. Approve, yeah. And you're gonna do yield. You're gonna do a deposit, right? You're gonna stop prank. Let's do a quick assert here. Okay, but not 0. 6.32. No, this one. Okay. Oh, this is essentially this one. This one subtract this one. Okay, just do check on the balance. Next one is you gotta do check total deposits. Okay, good. Deposit IDs, everything is good. Deposit ID, expected ID. And okay, you do inference. Okay, good. And you have a deposit 0, very similar to the one above. Okay, good. Okay, and you gotta do VM start break owner, and now you can set a new. Alright, so here I am setting it to be 0.6 instead of 0.8, 0.6. Okay, that is done for the owner. Alright, so now switch to the user, stop prank, good. So now assert equal is gonna be, so you have 6.32 E18 and you're gonna plus 1.2 E18. So yes, so add this conversion rate for ETH to vETH token conversion rate at 0.6 is gonna give you this 1.2. You can do a check on that. Yeah. Yield Delegation Vault to deposit and assert equal Yield Delegation Vault. This one is get depositor to record user. Okay, I need these to be 0. That means it's deleted. Right, so you check if you're able to withdraw the correct amount, and then you check if it has been deleted. The record has been deleted. Okay, let's do and run a test again. Okay, good. We got 3 tests done. Okay, let's go for another test. We are test now. We'll test the owner able to withdraw. So function test owner withdraw yield, and we're just gonna withdraw veth. So very similar. You're gonna create order. You're gonna do a approve deposit. Okay, good. And you're gonna call deposit of that amount. And let's do 2. So it a little bit different. Okay. So yield delegation deposit, two different deposits essentially, for us to check if the total amount is being added correctly. Yeah. So you're gonna start praying, which is turns into the owner. and you're gonna have set token conversion info, which is very similar to one above. Okay, and you gotta do Yield Delegation Vault, owner withdraw yield, and you're gonna stop prank. And okay, you don't need to. So you're gonna do assert equal balance. It's gonna be this 1.2. No, it's gonna be 0.8. Yeah, so that's the yield. So once you get to this, that's how much yield you're able to extract. Oh, the owner, yeah, 0.8, 18. Okay, let's do a quick check. Okay, essentially is you do 2 deposit 1.6, right, at the conversion rate of 0.8, and then over time the yields accumulate, right? So then that's what you get out of, right? 1 point, yeah, so you withdraw back 1.2 here, right? So then the other side of the equation is the yield, which is this much. All right, let's do this one. And 4 tests pass. Awesome. And that's how you run the test setup, right? I will also do another one that a deployment script and help you guys on how to structure the make file, right, for you to be deployed easily on any chain. All right. Okay, so after we finish the testing part, we're gonna go into the we're gonna do deployment, right? So we're gonna do another script. It's called deploy yield delegation vault, right? Now, as of so, nicest thing is like you. This is something I should do. Will put a blank script file, so you have something just immediately be able to like copy, right? But in our case, let's copy this one, right? And let the AI to do all the fixing, only return that part. This one, let's use delegation vault. Let's not need to import these ones. I don't think you would need to import these ones. And then you just it autocomplete the address. No, not very smart, I guess. So you get the so in here, let's say we want to do it for base. Alright, so let's wrap these ones, and let's get the AI to do this based on this. Give add in the addresses here. Okay, I usually do this to make. In reality, I think it's better that you copy it instead of letting AI to do it, because AI gets wrong all the time. But yeah, just kind of show off a little bit, how AI handles things. Yeah, don't trust them. You don't need dot address, that's for sure. Okay. Stop. No, stop. Okay, so let's just go here. Deployment. Alright. Base Apolia. Okay, good. And just need v dot. Okay. Okay, good. I don't need dot. Okay. So now, once you get to this one, you want to start podcast. You don't need any of these ones. Okay. So let's delete that. So we're gonna do small console lock. Right, so we see deploying. Okay, good. Deploy. And it's gonna be this. And how great is autocomplete. This is the minimum amount. It's gonna be 0.001 ether. And grab the address. Console lockout. Okay, return. You don't need these ones. Alright, that's it. That's all you need to deploy. Let's jump over to the make file. Right. In the make file, let's go to the end. What you do is deploy Yield Delegation Vault. But I want base. Okay, and automatically does this one for you. RPC URL, account dev, all that stuff, right? Verify to scan. Okay. So once you get to this part, you would need to load up your environment variables over here. Right? I have an example file here that you can grab. So you definitely need like the base Sepolia RPC URL, which is usually taken from Anchor. You just go create an account, grab the RPC. You also do need an Etherscan API key, and you do sender. Sender is like you need that for the feature from Foundry, which doesn't require you to put the private key inside your .env file. You don't want to do that, so make sure you do cast wallet. You set up your wallet with the name, and for me, it's called dev for me. And also you gonna specify the sender, which is the address, just the public the public address that you just put it in, and it would do that for you. And that's pretty much it that you need to do deployment, right? And make sure once you load up the env variables here, you go to this one, go to make sure you source it, right? And let's just do deploy, right? So make this one. Let's go grab this one. Okay. This one. And boom, has been deployed. That's the address, right? You got the hash, you got the address. So you grab it, and it will also do the auto verification as well for you. So you just grab this one, right? Easiest is grab this one, command click, and it would take you to there and verify, right? Yield Delegation Vault, everything's here. Perfect. And that's it. That's all you need for you to be able to build a Yield Delegation Vault. The code is going to be available inside the Bifrost dev kit, right? Available on GitHub. It will be inside this video descriptions. So you can just grab the code and just make experimentation with it, and without having to deal with that. But the video will come with it for you to really understand how the architecture works, and for you to be able to build even more things with this. And I hope you do. All right. Anyway, that's pretty much it for the workshop. Thank you so much for joining. All right. Stay tuned for the next workshop. All right. Anyway, have a good day.